Hello friends, welcome to DM's Math and Finance. Today we'll discuss the important concepts governing probability. In one of our videos we have already discussed it for class 10 CBSE. Today we'll take it up for little higher mode for class 11, 12 and JEE Main exam. Those students who are preparing for class 12 board and JEE Main, these concepts are actually pretty important, because without understanding these concepts, approaching the questions will be difficult and you may not be able to solve the questions. So these concepts will make you understand the why of that problem. So once you understand the why it is happening, the solutions becomes easy. So these important concepts, one, we start with a simple one: sure and impossible event. Sure event, as you know, you already have studied in class 10th, is something where the event is certain to happen. So usually that is expressed with a mathematical expression of S. Similarly, an impossible event is expressed with a mathematical expression of phi. If impossible event is something which is not going to happen. Take for example, suppose through weather report you come to know that there is going to be real heat today in the day. It was around 38-39 degree centigrade temperature and the possibility of rain is actually 0. Then it becomes an impossible event. You can express it through phi. After sure and impossible event, we have to understand what are simple events and what are compound events. Simple event is if only one sample points of a sample space happens, it is called as simple event. It may sound little tricky, but we can understand it through example. For instance, tossing the coin twice. So if we toss the coin twice, then what happens? What are the outcomes we get? The sample space S equals to HH. We can get head head, we can get head tail, we can get tail head, and we can get tail tail. So there are 4 simple events in these sample spaces. What are these 4 simple events? Events means the outcomes. So these are HH, E1, E1 we can denote it as HT, E2 we can denote it as TH, and E4 we can denote it as TT. So these are 4 simple events within the sample space that is happening. So this is called simple event. Then what are compound events? Let's understand this. Compound events is when there are more than one sample points, it is called a compound event. Here the sample point is actually 1. You see that HH 1 sample point, HT 1 sample point, TH 1 sample point. So these are simple events. But here in a compound event, the sample points are actually higher, more than 1. Then you call it as compound event. So suppose if you toss a coin thrice and the question asks you that we have to find out for event E exactly one head appeared. Another event, find out that at least one head appeared. Here exactly one head appeared and here at least one head appeared. Understand the play of the words. Here exactly one head. So only one head should come. We'll find out where there is only one head that has come, one H. Okay. Then in the second it is called at least one head. So it can be one head, it can be 2 heads, it can be 3 heads. So approaching these kind of questions, you have to understand the play of the words, okay, to get your answers correct. So let's find out what are the compound events. In the E, exactly one head appeared is how many? HTT 1 head, THT, another TTS 3. So in the E there are actually 3 events that are 3 sample points. So this is a compound event. Also, if at least one head appeared, we have to find out. We have already discussed it. At least one head means one head or more. It can be more than one head also. So HTT there, here there is one head. TST there is one head. But in HHT there are 2 heads. In HHS there are 3 heads. So at least one head means one or more than one. So here you see in this the how many sample points? 1, 2, 3, 4, 5, 6 in F. In sample space F, there are 5 outcomes. So this is a compound event. So each of these subsets contain more than one sample event. That's why it is called compound event. Now we have to, you must be recognizing the Venn diagrams here. Set as a chapter is very important to understand the concept of probability. So if you are not well versed with the set, then please go back to the set chapter and read it out. Of course we will do certain classes on the set also, but to understand probability you have to understand set theory and you have to understand permutation and combination. These two are very directly integrated with the probability chapter. So here then we come up with a complementary event. What is a complementary event? We have already found it out. A dash, if you can remember in class 10. A and not A. Not A is usually expressed as A dash. These are complementary events. Something is going to happen and something not happening. This is there. We will play football. So if we play football, we will not play cricket. So A is playing football, not A is not playing football because you are playing cricket. So these are complementary events. So PA plus PA dash equals to 1. We have already read that. We have already studied that in the previous classes. Okay. So you can see in this Venn diagram there is, E is one sample space, S is another sample space. Okay, if E happens, S doesn't happen, S happens, E doesn't. The outcomes of the E are very separate from S, and outcome of S is very separate from E. So we can say that. So the event, second one is the event A or B. You have to understand this is the additive theory of probability. What A or B is the actually A plus B. Understand this. Or this sign is union sign. Okay, A union B. Okay, so when the question comes the event A or B happening, so you have to actually find out that both A and B are happening. You have to understand that. Okay, so event A or B is usually expressed as A union B equals to W belongs to A or W belongs to B. W is the outcome or the event. So event belongs to A or B, A event belongs to B. Look here, A in the look at this Venn diagram, A and B or B. So here it is A, here it is B. So A or B, the whole A and B are actually coming. This is the additive theory of probability. Okay. Then let's discuss another one, the event A and B. Suppose what is A and B then? Okay, suppose A has 1, 2, 3, 4 as outcomes. B has okay, 2, 3, 4, 5 as outcomes. You can find out A has 1, 2, 3, 4. B has 2, 3, 4, 5. So what are the common points? 2, 3, 4 are in A. 2, 3, 4 are also in B. Okay. So what are the common points is usually expressed as A and B. Let's see the Venn diagram here. Here it is A and B. Look, the commonality, the common outcomes between A and B is expressed as A and B or with this sign. Okay, so we get it. So you will not be confused. This is the A, this is the expression, and here it is mathematically expressed as W belongs to A and W belongs to B. A or B, W belongs to A or W belongs to B, that is A or B, additive theory. Here A and B both are the common factors are being found out in the A and B. The event A but not B, can you tell me that? A but not B. What is the expression? Means A minus B, simple. Or A, the common factor between A and B dash, because if B is not there, not B means what? We have already studied. Not A means what? A dash. Not B means what? B dash. So A and B, the B dash, the common factor is A but not B. Similarly, what are the mutually exclusive events? You can actually A but not B, you can also find out from here. It is not there in the Venn diagram, but you can actually find out A not B. Which are not B? This is not B, complete. So this space, okay, this space is not the shaded place. If you A minus B means B is completely, I was subtracted from that. So B, the sample spaces, the outcomes are all out, and only A, not the barring the shaded part, is actually A and not B. Okay, so you can find it out through the Venn diagram. Venn diagram is very important. If you understand the Venn diagram, actually you can answer the questions properly. Then the mutually exclusive events. In the mutually exclusive events, it happens that if occurrence of two events are disjointed. So here, suppose say there is A and B, both are jointed. There are common factors. Here A and B, you can see there are A or B, there are common points. If we have A here and B there, and they don't have any common point, these are disjointed event. So A has in the disjointed events, let's take an example. A is 1 2 3, B is 4 5 6. What are common between them? Nothing. So these are disjointed or mutually exclusive events, or because the two events A and B are disjointed. I'm keen to give you a home task for this. If you like, then you can try this problem using this very concept which we have just discussed. Here the question is that two dice are thrown. The events E, F, G have following features. E has what? Getting even number on first die. What is the die? When two dice are thrown, 1 2 3 4 6, 1 2 3 4 6. Okay, E getting even number on first die. What are the even number between 1 2 3 4 6? We have to find out. Getting odd number on the first die. G is getting the sum of number on the dice wherein it is less than equal to 5. Find out E and F. What are the common outcomes between E and F? Second one is E but not G. So E minus G, like we have just found out now. A not B means A minus B. So E minus G, it is asking that. 3 is E, B dash and C, the common point E and B dash and C dash. Okay, so you have to find out what are the common points between E and B dash and C dash. Find it out. In the next class, we'll solve this problem. Thanks a lot for your patient hearing. It will be really good if you understand these concepts well and also practice some of your set theory problems well, so that to have a good hang on the subject of probability. Thanks a lot for your patient hearing. If you like this video, kindly refer it to your friends. If you have any doubt, kindly write it out on your on the comment section. Thank you. Thanks a lot. Have a great